Alright, so for Uber, the problem you wanted was to figure out the area enclosed by r of theta equals negative sine theta. And I found the way to do that, and the key is that the area enclosed by a polar coordinate function is equal to 1/2 times the integral from whatever to whatever for the enclosed region, in this case from 0 to pi, of that function squared d theta, which means we're doing 1/2 times the integral from 0 to pi of -3 sine theta all squared d theta. Alright, so we've got that much going on, and then we can simplify some stuff a little bit. We can do the squaring of everything. -3 squared is 9. A product squared is the square of the product. That is, I do -3 squared, then I do sine squared. So -3 squared is 9 times sine squared theta d theta. So let me start a new board here, and I am trying to do 9/2, if I move the 9 out into the front, times the integral from 0 to pi of sine squared theta d theta, and then you got to figure out how to square, or how to integrate sine squared theta d theta, and there's a whole set of tricks to that. So note, and you might not come up with this right away, and that's okay, but note that cosine of 2 theta equals cosine squared theta minus sine squared theta, which means that if let me make sure I got this right here. If I rewrite this, I want to rewrite this just a little bit. I think I want to add sine squared theta to both sides. Then I get cosine 2 theta plus sine squared theta equals cosine squared theta. Yeah, and then I can subtract the cosine 2 theta on both sides and get that sine squared theta equals cosine squared theta minus cosine of 2 theta. Right? And then I'm using the different versions of the Pythagorean identity here. And then sine squared theta equals, and cosine squared theta is 1 minus sine squared theta minus cosine 2 theta. And then I can add this sine squared theta to both sides. So I get 2 sine squared theta equals 1 minus cosine of 2 theta. Divide everything by 2, and I get that sine squared theta equals 1/2 minus 1/2 cosine of 2 theta. So that integral is the same as saying 9/2 times the integral from 0 to pi of 1/2 minus 1/2 cosine of 2 theta d theta, and the d theta takes up all of that, of course. And then I could factor the 1/2 out, move it to the front, and multiply it by the 9/2 to get 9/4 times the integral from 0 to pi of 1 minus cosine 2 theta, all that d theta. So that's what we're really trying to solve here, is 9/4 times the integral from 0 to pi of 1 minus cosine 2 theta d theta. And of course you can split that up. You can call it 9/4 times, you can do the integral from 0 to pi of 1 d theta, plus, let's call it plus, the integral from 0 to pi of negative cosine 2 theta d theta, like that. And then you can do these integrals separately. This integral right there, it requires a u substitution, so you need some side work for that. You'd say let u equal 2 theta, and then you'd differentiate, then du would equal 2 theta d theta, and then, or not 2 theta d theta, just 2 d theta, sorry. And then you'd probably multiply by 1/2 on both sides to say that 1/2 du equals d theta. And you should be able to do the rest of the integration and the evaluation from there. So I'm going to leave that, the rest of that up to you, but that should get you started pretty well. Thank you. I hope that helped.